And the reason why I love the stories is because somebody looked up and they were able to make that connection. These stories have been told for hundreds and hundreds of years. And I love that too, because in a way, those stories are kind of reaching across to us from the generations of how people were connecting with the sky is still the same way that we do. And that tradition of trying to find ourselves in the sky is really one that's always been there.
Welcome to the PAM Talks. The PAM Talks is a student-led podcast showcasing the voices of researchers who are part of traditionally underrepresented groups in physics and astronomy. Each episode, we interview a new physics and astronomy mentor, exploring the universe through the lens of diversity. My name is Solveig Thompson. I am a PhD student in astrophysics at the University of Calgary. My research focuses on searching low-mass galaxies and massive star clusters for evidence of a central black hole using the James Webb Space Telescope. I hope to soon share my research with you in a future PAM Talks episode. In this episode of the PAM Talks, I'll be interviewing Jennifer Howse, the education specialist at the Rothney Astrophysical Observatory. During my undergrad at the University of Calgary, I was a summer intern there at the observatory, and working there helped to influence my decision to study astrophysics in grad school. Rothney is a very special place for me, and I enjoyed getting to know Jennifer during my internship there. So I'm super excited to be able to introduce you to Jennifer in this interview.
Hi, I am Jennifer Howse. I am the education specialist with the Rothney Astrophysical Observatory, operated by University of Calgary's Department of Physics and Astronomy.
Awesome. Well, welcome to the PAM Talks, Jennifer. Thank you so much for agreeing to be on it with us and letting us interview you. We're super excited. Could you tell the listeners who don't know about the Rothney Observatory a little bit more about it?
Yes, the observatory, like I said, it's operated by University of Calgary Faculty of Science, and it's an amazing research and teaching observatory. And we're located about 25 minutes southwest of Calgary. And it's grown reputation, of course, in the research area, but also the area that I have influence over is outreach. So we do our very best to be part of our local community. And then beyond that, we like to reach out to people in Calgary and hope that they come out, visit us, look through a telescope, and have an opportunity to enjoy our somewhat dark skies that we have.
Very cool. As you know, I was an intern at the Rothney Observatory, so I'm quite familiar with your work. But for our listeners, as an outreach specialist, what does that entail?
We do programs for school groups and also youth groups, Cubs and Scouts and guides come to the observatory, as well as seniors groups, pretty much you name it. We've done everything. We've even had dating nights at the observatory, believe it or not. And it actually went well. I think a few nerds were able to meet each other in a nerdy space. And so that went very well.
That's so fun.
And also like Rotary clubs, you name it, everybody's interested in astronomy at some level. We all look up at the sky and wonder. And so it's a great place for people to come and learn a little bit more about what the university is doing. And also it's an opportunity to maybe get an answer for that burning astronomical question that they've always had.
Very nice. So you mentioned the Cubs and Scouts come. How has that experience with the kids been?
Both the Cubs and the guides come in great numbers every year. So we have thousands of kids come through our door each year, including those groups as well as other youth groups. So I've been with the university now for 18 years. And so when we first started, I still remember really distinctly that I had a few parents come up to me and say, oh, yes, we brought out the Cubs, well, we brought out the Scouts, and they really had a great time. But we didn't want to bring the girls because we didn't think they would be interested.
Oh, no.
And I think, Solveig, you're a perfect example of you just happen to be a girl who's interested in astronomy. And so many of them are. And now I'm glad that we get, I would say, probably equal participation from the Embers and the Sparks and the guides, and even a few Pathfinder groups. Last night, I had a group of guides at the observatory, and it went so well. And these girls are so bright and get an opportunity to talk to them about science. I think parents are always amazed at their scientific literacy. These kids, they know so much. And really importantly from that they also want to keep asking big questions. So they understand, some sort of a concept that they might have heard. And so we talked a lot about sunspots last night, but then they want to build on that knowledge too. So they're engaged and they're very interested. And I'd love to be a part of that. If I can help them, it's not that everybody's going to grow up and be an astrophysicist one day, but I love the fact that they're learning some foundational science. One day they're going to be, for example, policymakers and understanding of science. Also, we're moving into this wonderful future that will involve more and more of near Earth space. When I was a kid, the opportunity to think, oh, yes, I'm going to work in some sort of space related industry was like zero to none. And now there's so many more opportunities. And the kids, for example, these girls, they were aged 8, 9, 10, and 11 last night. And they're going to be doing jobs in the future that I can't even imagine. And they'll be communicating on quantum computers and sharing data. And it's really amazing. And I think that some of those big ideas are perfect for physics because physics is always on the cutting edge of these technologies, whether it's light and optics or our understanding of nearer space or even our concept of the universe is all really so much about what the future possibilities and potential can be.
That's so true. I love the kids' programs at Rothney. But I also know you host other programs like the Public Space Nights, where researchers have an opportunity to share some of their research with adults and the general public.
So when I first started, there was a push. There was some people who were hoping that I would go in more of a little kid kind of a direction. So like, oh, let's talk about stars and planets, which there's nothing the matter with that. But I really wanted to create a place where adults can come and either rediscover their love for science or find an opportunity to learn something new. And so I always like to keep the space nights at an opportunity where researchers can come and share what they're working on. And so I like to think it's a benefit for our speakers as well as a benefit for our audience.
I've had the chance to speak there a couple times at those space nights, and it was a great experience. I also found it really useful for myself since it really pushed me to think about and improve my own communication skills.
It's a learning experience for you because you're learning how to communicate to a general audience, to be able to explain something that's very important or something that you are passionate about clearly and concisely so that the audience can understand it. It's a skill, absolutely a skill.
Mhm. So you're like one of the like a science translator. You take what the researchers are saying and then translate it into like layman's terms that everyone else can understand.
I hope so. That's what I try to do. Heaven knows I work with some very brilliant people. And my joke with always, this is a reference to The Office. When I talk, especially when it comes to quantum stuff, and I'd say, okay, explain it to me like I'm 8. And then they explain it to me. And then I'm, okay, explain it to me like I'm 5. Because I want to be able to break it down so that it is still correct and accurate information. That's very important to me, but at the same time, something that people can consume and understand and take away or figure out a way to relate it to their own lives. And then they can see the great value, the work that goes on with astrophysics.
It's such a skill, especially the deeper and deeper I get into my own research field. The more I know, and the harder it is to pick a topic for my favorites and break it down to its basics. I love that Rothney is able to provide that kind of public outreach experience for students and research. So, changing the subject, how did you become the educational specialist at Rothney? What is your background?
So my background, I actually have people walk away from me. You know, I have a weird job where sometimes I feel like I have to apologize for my education, but I work for it really hard. So I will say I have an undergrad degree in Indigenous history and very proud of that. And then I also have a graduate degree in museum studies. And so that's what I specialize in is outreach and, like I said, being able to take the technology, the research, the understanding of what we do at the observatory. And like you said, put it in a way that is consumable for the greater community so they can understand what we're working on and why we do what we do.
That's such an interesting background. How does your Indigenous history degree and your own background help influence how you approach astronomy from a non scientific perspective?
I'm a member of the Métis Nation, very proud of that. My family's background is in Blackfoot and Cree. It's part of Métis Nation of Alberta. Where I live is in District 6, but where the observatory is located in is in Ocuview in District 4. And it's been a personal effort on my part. I love learning about Indigenous ways of life, ways of knowing, philosophies, and understanding of perspective of our place in the universe, which is highly cultural. And I love learning about origin stories and how scientific knowledge was transferred. So if I can give you just a touch of a history lesson,
Of
the
course.
18th century, during the Enlightenment, there was a real effort, and I know I'm making this a little bit simplistic. However, there's an effort to essentially catalog and categorize. Biologists, for example, would spend so much of their career just arguing whether or not something was part of one genus or another, or one species or another. It was very important to have everything collected and categorized in a certain way. And that is very much different from, say, for example, pre-understandings of the interrelatedness of life. life, the land and the sky, all are interrelated and do not exist without the other. So it seems strange to them when you hear about things like, oh, how do you separate this plant from this? Well, the plants exist within this particular system. And so they talk in terms of interrelatedness. The land and sky, all of those connections are quite prevalent in cultural teachings and spiritual understandings. And astronomy is, of course, the oldest science. Everything on Earth has changed. It's always changing, always moving, always changing. However, we can count on tomorrow, the sun's going to rise in the east and set in the west. The Earth's spin and its orbit will continue around the sun. And that's the way it's been since there's been humans. And so it's a very consistent science. And so to be able to understand that motion in the sky is very important survival knowledge, but there's also, like I said, a lot of teaching that goes on with that connection to the sky.
Very interesting. Could you give any specific examples of Indigenous teachings of the sky? I'm very interested to learn more about that.
Well, for example, in Alberta, the southern skies are changing seasonally. And so there's wonderful stories going to be told, and the stories have a lot of science in them. It's interesting, though, it's incumbent on the listener to be listening for that, because sometimes the science is spoken in metaphor or it has to do with time and space. So give me an example of talking about when you would see the 6 lost boys in the sky, according to the Blackfoot story, that is related to the buffalo calving season. So there's an indication there of time and space and what's occurring on Earth and how that is linked to what you would see in the sky. And so the sky is a clock and a calendar, and it's also a very important part of wayfinding or being able to travel over land. So it's an obvious one when you're on the ocean and you think about Moana on her little raft sailing east to Hawaii, and she's looking around at the stars to figure out those links there so she can find her way. It's no different if you're traveling overland and you're on prairie, or if you're on an icy, say, northern Canada, and that's all around you is ice. Then you need to have that skill to be able to see how do the stars connect to what you're seeing on the land, to be able to move forward and not get lost. I mean, that was a dangerous thing if you ever got lost at sea or at land. And there's a lot of evidence of material goods that moved thousands of miles throughout North America pre-contact. And so that's how they were able to move, is that understanding of where things are connected. Where the Milky Way meets the horizon shifts throughout the year. And so I have kids that come to the observatory now, and they live in inner city, and they've never seen the Milky Way. Whereas 150, 200 years ago, all kids knew where the Milky Way met the horizon and how it shifted throughout the year. And so I think there's a real shame that there's that loss of traditional skies.
Yeah, as I know in Calgary, it's quite hard to see. And one of my first activities that I did as an intern at the observatory was Dr. Langell had me go out onto my street and look up at the stars, look for the Big Dipper and see how many of the Big Dipper stars I could see in my neighborhood, and then look for the Little Dipper stars. And I could only see some of the brightest, but you couldn't make out the entire constellation. But the Pleiades star cluster, that's like just visible in Calgary. And is the Pleiades star cluster, is that also the 6 lost boys that you mentioned earlier?
Yes, it is. Yes. And so there's that. And then, of course, in the Greek tradition, it's the 7 sisters.
Right.
And so I love the stories. And the reason why I love the stories because somebody looked up and they were able to make that connection. And so these stories, for example, both 6 lost boys, the 7 sisters, these stories have been told for hundreds and hundreds of years. And I love that too, because in a way, those stories are kind of reaching across to us from the generations of how people were connecting with the sky is still the same way that we do. And so the observatory is located in the foothills of southern Alberta. To the south of us is Blackfoot territory. And so the Kainai, Connie, Siksika are all south of us along the foothills. If you go towards the mountains and you head towards the west, the Stoney Nakoda communities are there. And then to the north of us is the Tsuut'ina. And we've been so fortunate that students from each of these nations have had an opportunity to come to the observatory and learn a little bit more about the research we're doing. But my favorite part is that I will share with them a story that I know. And there's often kids will come and say, I know a story. And then I get to learn a little bit more about something that they might have heard and learned from an elder. And once again, it's just enforcing this notion that certainly the observatory is under these traditional skies, and that many of these traditions are continuing with this younger generation, and that they're very excited about it too. And so that tradition of trying to find ourselves in the sky is really one that's always been there. I mean, you can look at cave paintings and you see people trying to make that connection to what they're observing in the sky. And so I think it's fascinating, for example, in some cultures, comets are considered bad omens. And I think that is a testament to what excellent astronomers there are, so that they understood all the usual ebb and flow and patterns of what they're observing in the seasonal sky. But a comet is something extraordinary, it's something to be watched. And then by saying it's a bad omen, it just means, okay, we have our regular patterns, we know what to expect, but now there's something extraordinary. So we're going to watch that and try and figure out what's going on there. And I think that along with many other indications of how people have always been excellent observational astronomers. And I think that's not necessarily true today, unfortunately. If, say, most people live in cities, they don't get to see the night sky. And so some of those opportunities to connect with nature just aren't there.
Yeah, I was just thinking that, like, living in a city and growing up in a city, I never saw the Northern Lights until, like, very recently. Milky Way, same thing, didn't know where to look for, what to look for, since it's so hard to see. So we've really lost that sense of connection with the night sky, with the growth of the cities and the light pollution. And speaking of light pollution, since Rothney is so close to the city, I know when I've been down there at night, you can see the glow of Calgary to the north, and that really impacts what the telescopes down there can detect and pick up.
Exactly. And a good example of that, of course, we can see from the observatory, we see very easily with our eyes, the Big Dipper. But what I haven't seen, and it's a rare night that I'm able to get conditions where I can see the Little Dipper, because our sky is washed out from all of that, that ambient light, that glow. And on so many levels, it's a waste, and there's no need for us to light up the sky. And yet we do. And we overlight, and we also use too much blue light at night, which is very harmful for us. And yet, but I think the part that disappoints the most is that the technology is there. We can create smart lighting. We can put the light down where we need it. We live in a 24-hour society. I do not doubt that we need lights. We need to be able to see and drive and move and security, all those things that we need lights for. And yet we, for some reason, don't do it very well. And there's so much smart lighting, like I said, directs the light down exactly where you need it. More yellow spectrum. Blue spectrum is great during the day. If you're busy and you're working and you get that lovely blue spectrum light from the sun, great. But probably a lot of people are familiar when you hear that don't have your cell phone on at night. And that's because if you have it on a blue light setting, it's actually quite harmful and it interrupts your circadian rhythms. And so people who work at night, there's been some evidence that being exposed to light at night all the time, say, for example, nurses who work long hours, now they're finding that they're relating that to some cancers that they might be getting. So just like I said, thousands of years, we've had that rise and fall of the sun. We've had a darkness at night, and that's the natural sky. And so when we've evolved with that natural sky, so it's just now in the past, would we say 100 years, 50 years, that we've, of course, it's such a human thing. It's like we had a good idea, but we do it too much. And it's still a good idea. There's places in the world where they still have issues with access to electricity or lighting at night, say that they have problems, say, for example, lighting their hospitals at night. Why is that happening in the same way as why are we overlighting, say, for example, in Calgary? And we have an unfortunate distinction in Calgary and north of us in Edmonton to be some of the brightest places in all of North America. And that's not something to be proud of.
So if people are concerned about light pollution, reducing their own light pollution, they should switch their outdoor lights to more yellow base lights at night to reduce the blue light, and install light fixtures that force the light down as opposed to up into the sky. Is there anything else they can do?
And so when I use the word smart lighting, really what that means is just have a think about what you're doing. Exactly, your suggestions are great. But say, for example, if you think, okay, so you're going to park and then you want to walk in your house and you want to have a lit area to walk. That is a perfectly reasonable thing to do. So then it took you 30 seconds to get from your car to your home. And then you've left that light on all night long for 12 hours. And so why do you have that light there? And that's the question. And so it affects, certainly biologically, it affects humans in really unfortunate ways that we're still learning about, but it affects insects and plants and trees and animals and birds and you name it are affected by this overlighting. And it makes life very hard for them, especially birds or migrating birds have issues with too much light. More we study, it's called scotobiology, more it's studied, for example, think that there's migrating birds that are following starlight. And that's how they know to follow their migratory paths. Amazing. So why not help them and turn off a few office building lights that are unnecessary overnight, And so that's why I say we could do things smarter and more in balance.
Of course, just being more conscious about the light that we are using and being in more tune with the night sky sounds like we will benefit, astronomers benefit, and nature in general will benefit.
And I can definitely see how people today might know less about the skies than before. For example, I've had people ask me what the Pleiades star cluster is because they can just barely make it out within the city and they want to know more about it. And it's actually an open star cluster, and so it's a bunch of new stars full of gas and dust.
By far, my favorite thing to observe with kids at the observatory is Orion, because Orion's got it all. You
That's
can
my
see it.
favorite constellation.
Yes. So it's very consistent in its shape that many, many cultures consider it a guy in the sky. With his belt and his shoulders and his knees. But the fact that we can see a star forming region, we can see a old dying star, and like Ryan's got it all. And of course, being in Southern Alberta, it puts on quite a show from February until April. It's in a perfect part of the sky to be observed.
Yeah, I always remember seeing it at nighttime coming home from Ringette, and I'd look up, getting my bag out of the car, and I'd see it over my house, and I just would stand and stare at it, looking at Betelgeuse,
Yes.
the bright old star. And then now that I learned that there's a star forming region in Orion's sword, just below his belt, I now try and see if I can make out that it looks fuzzier. And then
Yeah, absolutely. And so there's our personal connection like that. And then you hear about, particular research that's going on that's looking at it in a new way. And that's also what I love. I love talking to students about being able to observe different wavelengths of light. Good old Jupiter. How many times have we all had a look at Jupiter in the sky? And then all of a sudden you see a James Webb image and you're seeing it in infrared and it's brilliant. And there's so much more to see and learn with good old Jupiter. And so there's that. And then, of course, seeing it with different types of telescopes that allow us to observe in different ways as well.
Now, how many telescopes does the observatory have?
There's 5 research telescopes, but my favorite, of course, is the one it's our solar research telescope, but it's also the one that I use for public outreach. And that's because it's easy and it's old school and you can still look through with your eye, which is still a fun thing to do, to be able to look through the telescope and to be able to observe something. We would always laugh with kids when they would come and they would look through and they'd see something as spectacular as Saturn. Saturn is such a wow thing to be able to observe, but I'll have kids that they'll look around the telescope because they're trying to figure out if they're looking at a picture. And I just say, no, that's the real deal. Like you're actually looking at the planet, and that really blows kids away.
That's so amazing. That's a great reason why it's a favorite telescope, just being able to see it with your own eyes. It's something different than running a larger telescope that can take much higher quality pictures. There's more detail, but that loses the magic when you just can click a thing that collects the light and then a minute later it appears, seeing with your own eyes and actually seeing what astronomers hundreds of years ago would have seen. And it's really something special and kind of brings you back to why I got into astronomy in the first place.
Right. And it's that active participation of being able to observe. It's a huge deal. During the pandemic, we were close to the public for about a year and a half, I believe. And it was such a thrill to be able to open up again and invite the public back again to have their own Galileo moment where they can see the moons of Jupiter orbiting around. And it's quite a spectacular thing to see.
And if the public wanted to come to the observatory to look through the telescopes, how could they find out more information and where to look?
So all of the information on our public events is on our website. And just so people know, like I said, we are a field station, we are a research facility. So we are not open to the public every day, all the time. What we are is we only open up during our events. Or sometimes, like I said, we have school groups coming, but that's always prearranged. And the reason for that is, like I said, we are a research center and the astronomers need to do their work. We also have the SOAR group, SOAR. The SOAR group is from engineering from the University of Calgary, and they've got an installation there. We've got the quantum people with a quantum station, which is shooting lasers at satellites. And so there's all sorts of scientific equipment out there doing work. And so we just open up at certain times. And so we have space nights. But in this summer, we have something called Milky Way Nights, and that's the last weekend of July. So it's the Thursday, Friday, and Saturday nights, and you do need to book a ticket ahead of time. And you can come out, we open from 10 p.m. until 2 a.m. So it's late night observing. So there's no talks. It's just all about coming and having that opportunity to look through a telescope and check out the sky. And so for me, it's quite gratifying because now I have undergrad students come up to me and said they remember when they were a kid that they came to the observatory, that their parents woke them up, they came in their pajamas, and they got a chance to look through the telescopes and see some amazing things. And it stuck with them. It had an impression with them. And so that's wonderful for me to hear that there's a legacy there. So we're hoping that we're communicating and teaching science. And so to have it resonate with people, that's a wonderful thing. One of my favorite stories is that the current president of the physics undergrad club, she came to the observatory when she was in grade 4.
Oh.
And so I like to think that, that hopefully I had a little bit of a positive influence on her. And then she joined the dark side and now she's an astrophysics major.
I'm sure you did, Jennifer. You're an excellent person for communicating science, getting people excited about it. Jennifer, I believe there's a fundraiser going on with the observatory currently.
It is fundraising. What it is that there's been a change in the Alberta curriculum. And in order to respond to that, I had a real good think because thought, what could we do? Because now grade 4s and 5s, as well as 6 and 8 and 9s, all are being introduced to astronomy. But really important, I thought the basis of that is light and optics. And so I thought this would be a really great opportunity for us to create in the Interpretive Center an optics lab so that when students can come out, they can learn a little bit more about principles of light, how light works, how we do what we do with the telescopes, which is important. But the light and optics is really cutting edge of where technologies are going in the future, whether it's healthcare or computing. There's so much to learn, and it's a basis of so much, like I said, technology and science now. So I thought this was a great opportunity as the observatory could be a place where kids could come and learn a little bit more about that. And then hopefully, if the skies are clear, also have a chance to look through a telescope.
That's fantastic. If anyone wants to learn more about this fundraiser or donate, where can they go to learn more?
They can go to the Rothney Observatory website and just go to our community page under donate, and you can learn a little bit more about what we're working on.
Fantastic. I can't wait for that optics lab to be up and running. It's a fantastic opportunity for those elementary students. Well, Jennifer, we've come to the end of our interview. Thank you so much for agreeing to be on our podcast. We're super happy to have you. I can't wait to see you at some of the future space nights, and hopefully we drive some traffic to you over there.
Thank you so much for inviting me. As you can tell, any opportunity to talk about astronomy, I'm there and I'm happy to do it. So I'm really grateful that you asked me to join you today.
Great.